Why is kinetic energy not conserved in an inelastic collision? Conservation of momentum transpires in both elastic as well as inelastic collisions. Momentum is sustained, but kinetic energy is not sustained in the occurrence of an inelastic collision. Thus, it would be converted into some other form of energy. In an inelastic collision, the system's momentum before the collision will equate to the system's momentum after the collision. But the kinetic energy is lost to the surrounding by converting into heat or sound or into some other type of energy form. Therefore, sometimes the colliding objects stick together, though this property highly depends on the material of the body. For example, let us consider two balls made up of the same material with equal mass, m, and move towards each other with equal velocities, u. The initial total kinetic energy for this system can be given as half of mu square plus half of mu square is equal to mu square. Now, they stick together as soon as they collide. This conserves momentum, but the system's kinetic energy after the collision will become zero. Such a collision is regarded as a perfectly inelastic collision, as the reduction of kinetic energy in this collision is highest than any other collision. It is easier to answer the question, is kinetic energy conserved in an inelastic collision? With the help of the example of perfectly inelastic. Sometimes, one object drags another object. This happens when one object has greater mass than another object, or when one object is at rest. How is kinetic energy conserved in an elastic collision, but not in an inelastic collision? Kinetic energy will fabricate into other forms of energy when an inelastic collision transpires. When the objects collide, more often than not, there might be a rearrangement of atoms or molecules inside the body, due to which the kinetic energy is converted into another form. Hence, it is not conserved. As mentioned earlier, the material of the object plays a significant role in deciding if the collision will be elastic or inelastic. If a rubber ball is thrown towards a wall, it will rebound when collided. As a result, we can say that it is an elastic collision. But if a glass ball is thrown towards a wall, it will immediately break into pieces when collided. Thus, as a result, we say that it is an inelastic collision. In the case of a rubber ball, the ball was deformed, but for a very brief moment, and all the energy worked to reform the ball to its original shape and size. Therefore, it is an elastic collision. In the case of a glass ball, all the energy worked in breaking the ball. Consequently, the bonds between the molecules were broken and a sound was produced. Therefore, it is an inelastic collision. In both cases, work was done, but the energy was transferred into different forms, which caused the collision to be either elastic or inelastic. Thus, with the help of this example, we can answer the question, is kinetic energy conserved in an inelastic collision? FAQs. With the help of a few examples, let us try to answer the question, is kinetic energy conserved in an elastic collision? The formula for collision in one dimension is given as V1 equals V2 equals, where V1 and V2 equals final velocities of object 1 and object 2, respectively. U1 and U2 equals initial velocities of object 1 and object 2, respectively. M1 and M2 equals mass of object 1 and object 2, respectively. CR equals coefficient of restitution. Coefficient of restitution? It is the ratio of final to initial velocities of objects after the collision. If the value of the coefficient of restitution is 0, then it would be a perfectly inelastic collision. If the value of the coefficient of restitution is between 0 and 1, then it would be real-world inelastic collision. And if the numerical value of the coefficient of restitution is 1, then it ought to be a perfectly elastic collision. The formula for perfectly inelastic collision. When a perfectly inelastic collision occurs, the objects stick together and move in one direction. The formula for this scenario is given as V equals, where V equals final velocity of the system. U1 and U2 equals initial velocities of object 1 and object 2, respectively. M1 and M2 equals mass of object 1 and object 2, respectively. Hence, with the help of all these examples and questions, we were able to answer the question, is kinetic energy conserved in an inelastic collision? Please visit our website lambdageeks.com for more articles on technology, engineering, mathematics, and various other domains. Scientific calculator and many more other tools.